Good afternoon. Hi, I'm Alex Russell. I'm a software engineer at Google, and I work on a product called Google Chrome Frame. And I'm here today to tell you sort of all about it. Google Chrome Frame, in a nutshell, is a plugin for Internet Explorer that lets you use HTML5 right now. That's sort of the simplest explanation I can come up with about Chrome Frame, is that it lets you use HTML5 today. No interruptions, no questions about backwards compatibility. You can start building things with HTML5 without worrying about how you're going to support old versions of IE. We'll talk today through the rest of this talk about how you can use it, how it works, how it's compatible with all the rest of the content that you might already have on your intranet or that your clients might have when they're using legacy browsers. But sort of to be a little bit more technically accurate about it, Google Chrome Frame is a plugin that's built on the open source Chromium project. And it is an Internet Explorer plugin. It's implemented as a browser helper object. And we'll talk a little bit later about what that is and how it works. And it lets you, as a developer, choose whether or not you would like your page to be rendered in Chrome Frame. And if a user has Chrome Frame installed, they'll see it. So users and developers both get a choice in determining how a page is rendered when they have Chrome Frame installed or you're targeting it. And maybe the most important part about Chrome Frame is that for organizations and users who have legacy content, legacy systems, or legacy browsers, it allows the content that they need to continue to work on the browsers that they have today. So before we get into the details and I tell you all about how it works and why it works and all of that, I want to show you a couple of demos. The first, of course, being this presentation. So for those of you who are unfamiliar with Chrome Frame as a product, the simplest way to think about it is that everything outside of Chrome Frame is IE, like you'd normally expect it. So what we're seeing here is a presentation being rendered in IE8. As you would sort of normally see IE, the toolbars are the same. I can come up here and I can go into the tools and the menus, and everything is sort of the same as you would expect. But if I come in here and I right-click on this menu, we'll note that the right-click menu is not the right-click menu from Internet Explorer. This is the right-click menu from Chrome, more or less. And in fact, all the tools, the developer tools, the great, wonderful, hugely productive web inspector that's available, including the command line console, resource inspection, audits, the console, sort of all that stuff is available to you as a web developer when you're using Chrome Frame inside of Internet Explorer. And again, from the user's perspective, this is just IE. I can open new tabs. I can navigate to new URLs. And if I navigate to a URL that's not rendered in Google Chrome Frame, one that hasn't opted in, say google.com. There it is. So google.com is a web page that hasn't yet opted in to the rendering for Google Chrome Frame. And if I come back here and I right-click on this menu again, we'll see that this is the normal IE right-click menu, right? This is the same thing I would get if I was just navigating around the web on the web with Internet Explorer today. So Google Chrome Frame allows pages optionally to opt into this rendering. So let's look at a couple of other demos very quickly here. Go back to full screen mode. So, wow, how did I miss these? YouTube, as you may have seen yesterday, has announced support for HTML5. And so what we're seeing here is the HTML5 version of YouTube running with the video tag, the audio support system that you'd normally expect, running one of my favorite Google Chrome ads in Chrome Frame using native HTML5 audio and video. So as you saw yesterday, the WebM codec is going to be supported in Chrome, and when that's available, that'll be in Chrome Frame as well. So new features that show up in the platform show up in Chrome Frame almost immediately, and you can start targeting them for sites that you develop against HTML5 in Internet Explorer today. So YouTube's pretty hot. That's great. We can use HTML5 audio and video tags. We can use high-performance codecs that Chrome supports, including H.264, Ogtheor, and now WebM as a great option. And the standard support is outstanding. So for those of you who are web developer dorks in the room, this should mean something to you. How many is that? Everybody? Nobody? All right. Is this good? All right. This is ACID 3 passing 100 out of 100 in IE8. And that's not because IE8 supports the ACID 3 test. In fact, if we copy this URL and we give this a go, just normally, the ACID 3 page isn't sending the header or the meta tag that we'll talk about in a minute. And this is the normal experience that you would get. This is sort of indicative of the standard support that you should expect for apps that are natively targeting legacy browsers. So it would be better if we could do better, right? So Chrome Frame allows you to start targeting these features almost immediately. So the question becomes, let's assume that I could start building an application today, and I could start targeting Google Chrome Frame. What sorts of things could I use, right? I'm a web developer. I started on the project coming from a web development background. And I've had this sort of continual process of unlearning and relearning how to do my job as a web developer. Part of that has been that there's a whole series of features that I heard about maybe a year or 2 or 3 ago that I sort of put back in the attic and said, yeah, that'll be great someday when I can use it. And part of my job now is to go and dust those things off and realize that if I target Chrome Frame, I can start using them almost immediately. And it's a very long list indeed. You may have seen some of the wonderful HTML5 presentations already. But the list of things that we could start building with today, if we could target modern browsers, is really sort of eye-opening. And each one of these could maybe revolutionize a single application. WebGL is coming. SVG and Canvas support are already in Chrome. All the animations that you're seeing in this deck are done with CSS animations and transforms. There isn't JavaScript driving any of this. The layout of this presentation, the drop shadows, the rounded corners, that's all being done with CSS. There aren't large amounts of images. In fact, I think there's three, maybe 5 images in this entire presentation, and 2 or 3 of them are diagrams, right? Everything else are background images. So the sort of dynamic range that you've got available in modern CSS, HTML, and DOM is really impressive. And in fact, it sort of changes the way we think about building applications entirely. And this sort of backlog of features that we could start targeting, if you go to one of the HTML5 presentations or have been to one of them, you'll sort of understand what we mean. But the feature list, the backlog of things that we can start to do is really powerful. So the question becomes, from many folks, why shouldn't we just install Google Chrome? And I think the answer is, you should. Please do. As a developer, I like it. The web inspector, as you saw earlier, is awesome. It gives me the ability to develop and debug things almost as fast as I can anywhere else. The JavaScript engine is outstanding. WebKit is an amazing layout and rendering engine. It has wonderful features, some of which we haven't even begun to scratch the surface of collectively. And as a user, I like Chrome. Chrome is a wonderful browser. It has great security features. The multi-process model keeps things from crashing and going badly all over the place when maybe one tab goes tilt or one plugin decides to chew a bunch of CPU. So Chrome is a great user experience. However, a lot of organizations aren't in a position to necessarily switch. So you may have worked at a bank or been to a university where there's a centrally administered configuration of Windows. You're not allowed to install anything as a user, or if you are, it's wiped when you log into the box the next time, or an internet cafe. Many organizations and users have a setup where even if they're allowed to install something at a user level, it may not be available to them the next time they log in. So for those organizations, they'll have to adopt a new browser en masse. They'll have to adapt their systems to deal with a new browser, and many of them are scared of changing a lot of systems that they might have bought from a vendor who may have gone defunct or who may not support new versions, or for whom buying a new version that supports modern web standards might be relatively expensive. So they may not be willing to move all of their infrastructure all at once to support a new browser. Similarly, you could imagine, let's take a small regional bank. They have an IT system that they bought from a vendor in the late 90s. It uses ActiveX controls, and they're critically dependent on it. It may not be the most secure thing that they've got, but it's something that they're critically, as a business, dependent on. They can't get away from it. So for these sorts of organizations, going to them and saying, yeah, you should use Internet Explorer for those applications, but then you should train your users to go use a different browser for other applications, seems like a difficult sell to me. If you can tell me how to do it, we'd love to know. But it seems like a difficult thing, difficult proposition to make for a lot of organizations. Specifically, the side-by-side installation management hassles for users calling the support desk or asking IT to come and help them figure out which browser to use where is a daunting prospect for a lot of organizations. So for the organizations that can, and for users that can, Chrome and other modern browsers are a great choice. And that's plan A. We want users to install and use modern browsers because they get the full benefits of a modern experience, whereas they might not with legacy browsers. But many organizations can. So Google Chrome Frame is a stopgap solution in many ways. It gives us the rendering engine, V8, WebKit, modern HTML, CSS, HTML5, and it puts it inside the UI of Chrome, or sorry, of Internet Explorer, as we saw before. And so it does this, but it tries to do this in a way that's not going to break existing content. So you could imagine that we could have written a plugin that, when you installed it, would render every web page in Google Chrome. But Chrome doesn't support ActiveX controls. We won't support ActiveX controls. Chrome supports plugins, but we support them out of process. There's a lot of differences between certain kinds of legacy content and the modern web, and it's impossible for Chrome to support all of those natively. So instead of that, Chrome Frame allows you to have the pages that render in the Chrome Frame mode only show up in that mode when the developer opts in. At the same time, users don't see that when they don't have Chrome Frame installed or enabled. If Chrome Frame is enabled, those pages will switch. But if they don't have Chrome Frame installed, it just falls back to the normal IE user experience. So that means that no page is ever ambushed. No page is ever going to render in Chrome Frame that didn't expect to be rendered in Chrome Frame. You as a developer, a web developer, opt into this treatment. Developers opt in per page. So let's say that I'm on a domain and I build a web application. You could imagine a different design choice where we might have said one page in this domain wants to be enabled to render in Chrome Frame, so we should opt them all in. That's not how it works. Every individual page gets an equal choice about whether or not it wants to be rendered in Chrome Frame. That means that you can have a login page that uses IE's rendering engine, and maybe your main application is rendered in Chrome Frame. And we'll talk a little bit later on about how we work to make sure that that experience is coherent between those two different pages. There's also no blanket rendering. That means that an administrator does have an option to push out a policy that would make many pages all render in Chrome Frame. But generally speaking, that's not how it's configured, and that's not how it works out of the box. And Chrome Frame, most critically, won't break the intranet. It's there to help you over the hump until such time as you can decide to use or deploy a more modern browser. But until then, this allows you to continue to work on those legacy systems, phasing them out and moving along your users and your IT systems in an orderly fashion to a better future. So how would you as a web developer opt into this better world? It's really easy. The best way is to add a single HTTP header to the pages that you'd like to be rendered in Chrome Frame. So for many applications, this is a single or maybe several lines in an Apache configuration file or an IIS configuration file. In fact, WordPress.com rolled out this header in a change to their HTTP daemon last week across all of their sites. It was a single change, and it went out everywhere. So for many organizations that don't have control over templates for applications that they may have purchased, this is the easiest and simplest way to make it happen. But as a web developer, this may not be the most convenient. So we also support a meta tag version. This XUA compatible flag, by the way, was introduced with Internet Explorer 8 as a way for IE to help switch different versions of its own internal rendering engine. We're just piggybacking on this sort of already existing usage of an extension header to allow you to specify Chrome as one of the options in the list. It's worth noting that when you specify Chrome along with other options, the Chrome option wins. So you get Chrome, and then you fall back to IE. So there's pluses and minuses to each of these methods. The header, the HTTP header, is the most reliable way of triggering Chrome Frame across your sites. When you use the meta tag, it has to be in the first 1K of the document, but the header doesn't have that restriction. Since headers, we see them all, it's easier potentially to configure it for your entire site and maybe slightly faster. It's unfortunate, though, that you will have to require a change to either your scripts or your HTTP daemon or some other part of your infrastructure that can set headers in order to make this work. You can't just open up a text file, type some HTML into it, and then have Chrome frame rendered with the header mode. You have to use the meta tag. You can use them together. The first one wins, obviously. And in many places, you may not be able to change your HTTP headers. So imagine that I've got a lockdown Apache configuration which doesn't have htaccess files enabled. It may not be possible for me as a user or a developer to set different headers. The meta tag method is great for prototyping. This is the easiest way to get started with Chrome frame. You just put this at the smack dab at the top of your page, just inside the head element in your document. And it's easy to get going with, and you can use it in conjunction with the other values for XUA compatible that IE supports. It's a little bit harder, potentially, to configure this across an entire site. So if you've got, say, a very large templated application, sometimes it's difficult to make sure that the meta tag occurs in the very top of the document. So say some other include puts content in the top of the document well before the first K and pushes you out of that first 1K. You may not trigger as reliably. And in some places, you may not have control over application or site-wide headers. So you have choices. You can use them both. You can use one or the other. But just be aware of the pluses and minuses when you go to use it. So the question, of course, is what happens when Chrome frame isn't installed? When Chrome frame isn't installed, you get the regular IE rendering of a document. And in fact, let's go and look and see what happens there. Chrome frame depends not only on being installed, but also on being enabled. So we can come in here, and we can disable Chrome frame. Manage add-ons. So I'm going to disable that. And this, unfortunately, will require a browser restart because enabling and disabling does. The install process doesn't, however. And just one second. Usually, users tend not to enable and disable add-ons, so we want to make sure that both aspects of it are disabled. OK, great. So let's go back, load IE, without Chrome frame enabled in any way. And what we're seeing here is this prompt. This prompt is provided by a script called cfinstall. But again, if we come back and we inspect this page, we can see that this is the IE context menu. This page is simply being rendered in Internet Explorer when Chrome frame isn't available or installed. So what we've got here is the fallback scenario. And this prompt is not something that happens automatically. This is something that you choose to do in your document. So I'll go back and re-enable Chrome frame, and I'll show you how that works. I'd like to enable both of those, yes. Great. What we're seeing here is cfinstall, that script, actually detected that Chrome frame was enabled while it was on the page and refreshed the page for me. I didn't even have to do it. That's how the install flow works, by the way. Once you install Chrome frame, the page is automatically refreshed. Users don't even have to restart their browsers. So while I'm forwarding to the slide that I was on, the down slide of HTML slides, the cfinstall script is a script that you add into your page optionally. It's not there by default. It's something that you have to do if you'd like to prompt your users to install for Chrome frame when it's not available by default. So if we go and we view the page source, again, we get Chrome's beautiful rendering of source, I hope. I really hope. Demo gods, please smile upon me. Oh, not so much. You will have to forgive me. I'm going to switch to Chrome for the rest of the presentation. I apologize. I tried something that was a little bit risky, and I paid for it. So the cfinstall script that we were just looking at, page source, that's what I wanted. I've added it to the bottom of my page here. So as you can see at the top of my page, there is the XUA-compatible meta tag, which has the exact same value that we would put in the HTTP header. So in this case, I can pass this HTML file around, and every user who sees it can experience Chrome Frame if they've got it installed. But at the very bottom of my document here, we've got a little bit of script that's in what is called a conditional comment. And a conditional comment is an IE-specific way for making Internet Explorer understand only particular pieces of content in the page. So in this case, we're saying, if the document is being rendered in Internet Explorer, which is to say we weren't flipped into Chrome Frame mode, we'd like you to go and request this script off of the AJAX API's content distribution network, which Google hosts. So this API, this JavaScript file, like many other JavaScript APIs, jQuery, Dojo, that you might have heard of, are hosted by us on our edge-cached CDN, so hopefully not to slow you down. And there's a single line there at the bottom called cfinstall.check, which says, when you detect that Chrome Frame hasn't been installed, use that overlay that we saw there earlier. Use that overlay and pop up that prompt to have your users install this. So if we were to put the meta tag or the header in the document, but not include cfinstall, we'd get best effort rendering. That means if the user has Chrome Frame installed, it would be rendered that way. And if not, it would just fall back. For a lot of sites, that's a great option. So you can add the header or the meta tag without any additional friction. It's a really simple one-line change to your website. And if your users have Chrome Frame, maybe they get the better experience, or they will get the better experience. If they don't, no big deal. On the other hand, if you're building something that targets HTML5 features explicitly, cfinstall and this two-line change to your document, or in this case 4 with the conditional comment, is a great way to help you make sure that your documents work everywhere and that users get the best experience possible. More fun with HTML slides. OK. So we just saw the cfinstall script at work. That overlay prompt asks users to install Chrome Frame. And in the general case, it doesn't require users to restart their browser. So on the server side, let's say you've got some code that's detecting for Internet Explorer and potentially sending different content down to the user. You'd like to know whether or not your users can see Chrome Frame. The way we make this possible for you is that we extend the user agent header that the client sends. Now, we don't extend it all the time. So when Chrome Frame is disabled but installed, we don't augment the user agent header with this string at the end. This tells you that Chrome Frame is available, that it's IE with Chrome Frame, and what version of Chrome Frame you're using. Generally speaking, all Chrome Frame users are going to be on the latest version because we use the same auto-update system that Google Chrome does, which means that most users are going to be on the very latest release within weeks of release. So if you've got a server-side script that's detecting, or some code that's detecting the user agent, you can look for this to know that you can send the meta tag or the header for users that have got it, and maybe direct them to a different experience otherwise. That's how Google Wave does it. So if Google Wave detects this, it lets users write on through to Wave. On the other hand, if they don't have it, they ask users to get a better browser or to install Chrome Frame as a result, because Wave just isn't designed for browsers that don't have HTML5 support. Again, it's worth noting that the user agent is only extended when Chrome Frame is installed and active. If we disable the browser helper object or disable the plugin, but it is installed, we don't send it. So you're never going to see that header from a client that can't handle Chrome Frame content. At the same time, we don't want to make it so that you have to change your scripts on the inside of your documents to be aware of Google Chrome Frame. So while we might send an augmented Internet Explorer user agent on the network, on the inside, when you query it from JavaScript and say navigator.useragent, the user agent you'll get back is Chrome's user agent. So if you have existing scripts that understand Chrome or are not doing feature detection but might be doing user agent detection instead, Chrome Frame looks exactly like Google Chrome from the inside. No changes necessary there. All of your JavaScript libraries should continue to work. So the key takeaway here is that so far, right, Google Chrome Frame is this little rendering area where the main document is, and everything else works exactly the way it should in Internet Explorer. Except the integration goes deeper than that. Instead of just rendering a document when we're asked to render a document, we make sure that we use the same cookies so that when you request a cookie in JavaScript, say, from a document that's being rendered in Chrome Frame, you see the same cookies that were sent to Internet Explorer earlier in the session. At the same time, we don't use a separate cache. We use Internet Explorer's cache. When you make a request across the document for a document or a resource that came across the wire earlier, you're going to get the cache behavior from IE. If you have Chrome installed on the box and Chrome Frame, we will continue to use IE's cache, not Chrome's cache. That means that when you clear the cache in Internet Explorer, the cache from IE goes away, and Chrome Frame doesn't leave trails behind either. We also have the same network behavior. That means that when we make a request for SSL, if you've got client certs installed, if you've got a special proxy installed, if you've got a pack file, that stuff all works as well. We use Internet Explorer's networking. Now, there's a couple of caveats here. That means that some network behaviors are slightly different in Chrome Frame than they are under Google Chrome. For instance, Google Chrome allows you to have 6 network connections open to any particular host. That's great if you're doing Comet-style applications or server push messaging. On the other hand, Internet Explorer only gives you 2 on versions before IE 8. And the result is that, IE 7. And the result is that, well, we might see prefetching behavior that looks like Google Chrome from Chrome Frame. At the network level, when we pass it off to IE, we'll get that 2 connection limit enforced. So generally speaking, things look at the network level like Chrome, except when we hit some hard limits that are at a level lower than Chrome Frame in order to make sure that things work the way you expect them to. We respect the in-private mode for Google that Internet Explorer uses in IE 8, has introduced in IE 8, and we use Chrome's incognito mode when that happens. So pages that are rendered in private browsing in IE trigger incognito mode for Chrome Frame tabs. Similarly, we respect cache clearing, cookie clearing, all of the same things that you'd expect to have happen for any IE-hosted web page. So how does this all work? Well, briefly speaking, navigation begins when a user clicks on a link, types an address into the location bar and hits enter, or in some other way opens a shortcut that's going to navigate Internet Explorer to a different page. When that happens, there's a small component sitting inside of Internet Explorer, the extension, the browser helper object that we talked about earlier, and that allows us to observe the request, and as we saw earlier, we augment the user agent string with that Chrome/version number when it goes out to the network. And when the request comes back, we try to determine whether or not it was destined for Chrome or for Internet Explorer. If it's destined for Chrome Frame, the Chrome rendering engine, then we create an active document server, render the page in Chrome like you would expect, say with a full-page PDF, which is the experience we saw earlier. And if not, we just render it, pass it right on through to IE. So the simple way to think about this is that there's a process for Internet Explorer. So this sort of resembles IE 6 and 7 on Windows XP. IE 8's a little bit more complicated because there's a multi-process model there. But for simplicity's sake, let's think about a single process Internet Explorer. So IE has a series of components down at the networking, disk, JavaScript layers that all sort of collaborate together. And when Internet Explorer loads, there's a supported mechanism called browser helper objects, which allow you as a developer to register some component to load with Internet Explorer. There's a very tiny component that's part of Chrome Frame that loads with IE in this mechanism. So when Chrome Frame is initialized, this small, tiny helper object is loaded when Internet Explorer starts. That doesn't mean that Chrome starts, though. So generally speaking, when you're navigating around the web with IE and Chrome Frame is enabled, this tiny component is observing what happens on the network to try to determine whether or not these requests are destined for Chrome Frame. Generally speaking, they probably won't be, because most pages today don't target Chrome Frame. So what happens when a page does want to be rendered in Chrome Frame? We observe the response, see that it should be rendered in Chrome Frame, and we fire up Chrome's multi-process model. That means that when a document is created that wants to be rendered in Chrome Frame, we launch Chrome, we create a renderer process, which is to say, sort of the fancy way of saying the separate OS process that renders things in WebKit, and we make sure that that happens inside of a sandbox. And we plumb all that through to an in-process active document server. For those of you who don't know what active document is, it's sort of the IE mechanism or the Windows mechanism for rendering some other content type that IE doesn't know about already. Think PDF or a Flash object. So as you can see here, we have the same benefits of Chrome's multi-process architecture in play in this model as you would when you're rendering documents in Chrome directly. That means that tabs that crash don't take down the entire browser. Security issues are mitigated because things are rendered inside of Chrome's sandbox, which means that vulnerabilities in WebKit don't turn into vulnerabilities in Chrome most of the time. And this architecture has several other benefits. Obviously, when you start up Internet Explorer, it's not slowed down significantly because we're not loading all of Chrome along with it. We only load Chrome when you ask for a page to be rendered in Chrome frame. We also have very small communication channels between the browser helper object, that small extension that's loaded with Internet Explorer, and Chrome frame and the Chrome browser. That means that the attack surface area for potential attackers is pretty small. And we do a lot of work to make sure that the Chrome architecture works the way it should in this model as well. We have separate infrastructure for making sure that when we launch Chrome, you don't see a window that pops up. And we can talk about that later in the Q&A if you're interested. So what users can benefit from Chrome frame? Generally speaking, the most widely used versions of IE are supported. We only support Windows XP Service Pack 2 and above because IE on SP1 and below didn't support the sandboxing primitives that we need to make sure that renderers can render content responsibly. So that cuts out Windows 2000 and earlier versions of Windows XP. But generally speaking, I think most organizations are off of those versions. The major caveat, of course, with Chrome frame is that it does require administrator privileges to install today. I can tell you that when we hit beta, we will be making MSI packages and group policy templates available for administrators to roll out Chrome frame across their enterprises. So many of the users who are in lockdown configurations may not be able to benefit from the per-user install nature of Chrome today. And so the easiest way for them to get it is going to be through their administrators rolling out Chrome frame, and we plan to make it easy for them to do that. When a user does encounter the Chrome frame initial installer, we saw that they don't have to restart their browser in order to install Chrome frame and start using it. And the initial download is very small. We use a system called Omaha, which is our installer package. And the initial download is 500K. The rest of it happens sort of in an automated fashion to ensure that there's a minimum of user hassle when installing Chrome. So for those of you who are C++ hackers, Windows people, maybe, anyone? All right, yes. Chrome frame is implemented as an ActiveX control and an active document server. That means that if you're building a desktop application that can use an embedded HTML rendering engine, you can use Chrome frame to do that. So as you might expect, we have a set of supported interfaces. We register these at the system level, which means that when Chrome frame is installed, any application can use them. They are scriptable, and the details of the interface that we support and are supporting is available in the chrome-tab.idl file. It's just a regular Windows IDL file that you would expect to see. And if you have questions about that, we have an active mailing list that we can help you with. The major caveat in all of this is that the ActiveX control and the active document server don't support synchronous access to the document object model. Unlike MS-HTML, we can't provide you with that usability nicety because it provides challenges for synchronization across the multi-process architecture for Google Chrome. Instead, we support HTML5's post-message and on-message system as a way for you to send messages to content hosted inside of Chrome frame and get messages back out. That's available in either the ActiveX or the active document versions. So we mentioned earlier that Google Chrome frame doesn't start up Chrome when IE launches. So what does it do instead? So it launches that small browser helper object, and when it detects that a page is destined for Chrome frame, it launches Chrome then. Chrome launches very fast. That's the good news. The bad news is that it still takes time, and we're not doing it up front, so we're not slowing down IE's launch, but your page might see a small hit. So what happens after that hit turns out to be just as important to your page. In some applications that are JavaScript heavy, we've seen the startup time for Chrome, cold startup time for Chrome, be totally more than made up for by the performance benefits from V8 and modern CSS. So we're working as hard as we can to reduce the startup time, and the warm startup time is perfectly acceptable today. It's on the order of hundreds of milliseconds. So the second page to use Chrome frame in a session doesn't have to pay the same cost. And so modern CSS, DNS prefetching, which is to say, when we encounter a page, we look down the page to see which resources we're going to need in the future, and we fire off those requests at the DNS level early so that we know that you're going to need them, you're going to be looking them up, and we can sort of pre-warm the caches on the OS level for those. And between all of those things, we tend to do very well in terms of performance. So Now what? Well, Google Chrome Frame was released to the developer channel last fall, late September. And it's been in that developer channel ever since then, which is sort of like our way of saying alpha. The Google Chrome team has supported these 3 different channels, developer, beta, and then stable, since Google Chrome was initially released. And the waterfall sort of looks like we release things from trunk on a very frequent basis in the developer channel. We make a branch at some point. That's beta. We keep fixing it, and then it goes to stable. So Chrome Frame is on the exact same trajectory. And I'm happy to announce that in several weeks, we'll be releasing a beta for you. So Google Chrome Frame, in several weeks, will be available for wider use. We'll be making MSI and group policy templates available for administrators to begin rolling it out inside of enterprises. And many applications are going to start targeting Chrome Frame. So we are in the developer channel today. You can go and download Chrome Frame. You can start using it. You can start developing against it. And we support all of the same features that Google Chrome does in the developer channel. We track Chrome releases more or less day for day. Today, the team is working very hard to improve the startup performance so that your pages get the full benefit of those high-performance JavaScript, HTML, and CSS engines without any of the lag for startup. And we're continuing to polish the feature set of Chrome Frame to ensure that it works exactly the way you expect it to inside of IE. That the back button works, that the print menus work, that everything works the way you expect it to. We're sort of filling in the menus, filling in the right-click system, making sure that all the systems work exactly the way you think they should. And in order to make sure that we are not missing any features, we want your help. We need your feedback, and we'd love for you to get involved in the project. As I mentioned earlier, Google Chrome Frame is a part of the Chromium project. So if you know C++, or if you're just a user who wants to understand more about it, we have a mailing list. You can go find it, and we'd be happy to hear from you and understand your needs. So you can get involved by going to either the main product site, google.com/ChromeFrame, where you can install Chrome Frame directly, or the Google Code site, where there's obviously links to the mailing list, documentation, support resources available for you to start using Chrome Frame. And I just wanted to mention that when the beta does go out, the developer channel will still be available for you to target features on. So there will be a new developer channel release that's made available at the same time as we did with Chrome. And so join the mailing list and keep your eyes out for that. So I'll take some questions now from the mics, and we'll see what happened on the moderator. Yes?
Yeah, question. Yeah, you haven't mentioned the behavior for, say, for example, you have a friend set. You know, is that partially like friend set? Some of the friend could partially be rendered by Chrome Frame, the others rendered by, or iframe kind of thing. You have a page, you have iframe. Is that possible for iframe render using Chrome Frame and the others, the traditional stuff?
That's a great question. So the answer is that Chrome Frame operates at the top level of a document, which is to say, if an iframe wants to be rendered in Chrome Frame, we only try to pay attention to top-level navigations. We don't switch into Chrome Frame rendering for individual sub-documents. It's very difficult. There's a lot of complexity around the scripting relationship between documents that are in the same domain through the web security model. And again, we don't support that synchronous DOM access, so we might break scripts if one script wanted to and one script didn't. It sounds uncommon, but it happens in very large organizations with a lot of things hosted on the same domain. That said, the ActiveX version is available. You can use it on a document individually. It acts a lot like an iframe. I don't recommend that you sort of target that unless you have no other option. But if you have questions about that, talk to me afterward or join the mailing list, and we can talk you through using that. Yes?
My 2 questions are both in moderator, but my top priority feature is print support.
Yes.
And I wasn't clear with this beta, is print support available in the beta?
So the question was print support for Google Chrome Frame. Print support is available. It's available at the level of Google Chrome's print support, which is to say, it's all right. It could be better. It could be significantly better, but it's pretty good. You can print Chrome Frame documents today. it doesn't work, let us know.
When
Please
you
file
say
a bug.
today, you mean today,
Yeah,
not
in
the
the,
beta.
in the developer channel. Just to be clear, we've been making new releases on a weekly basis in the developer channel since the initial release. So we've been adding new features, improving stability, making sure that crashes are reduced ever since then. So it's not like we've been sitting still. So if you checked it out a couple months ago and it didn't work that way, try installing it today, give it another shot, and let us
I
know
think
how
the
it
web
goes.
page still says it's not available.
Ah, okay. That's a to-do list for me.
And the other question is, what do you think is still in the path? Is it just fixing bugs and quality fixes, or are there major components you think are still needed before it becomes stable as opposed to just beta?
For my personal use of Chrome Frame, the things that I care most about are performance. So once a page is rendered in Google Chrome Frame, it's as fast as it is in Chrome, which is outstanding. Startup performance is currently our largest outstanding item on the trajectory towards stable. We want to make it so that you don't even notice that Chrome Frame is starting up, and I think we have a good shot at making sure that that happens. Generally speaking, though, otherwise, I'm happy with the way the fit and finish are today, and I think that we will be in stable. I can't promise anything, obviously, but hopefully shortly.
One last quick one. I'm just reminding myself, Google Chrome doesn't have print preview, right? Does that mean Google Chrome Frame doesn't have print preview?
That's correct. The question was, yes. Google Chrome Frame has support for printing at the level of Chrome today.
Ah, thank you.
Yes.
So last time I played with Chrome Frame, I was trying to use cross-origin resource sharing, the XHR2, and it totally crashed like everything. It all just went kaboom.
Can you explain this? Can you explain the scenario a little bit more? Were you trying to do that in a single document, or
Yeah. This was like 2 months ago, so maybe it's changed since then. I didn't know if it was maybe a network layer thing that IE doesn't allow it, so Chrome Frame can't allow it. But I had a page where I was trying to do a post to another site using XHR2, and it kaboomed.
And were you sending back any specific headers regarding the policy for display and subframes? Or were you simply sending back, I allow this document to use this cross-origin resource?
Yeah, I was sending back the everything that's like it works in other browsers and it works
If
in
that
Chrome,
does,
it works
if
in
that's
Firefox.
not working, it's our bug. Try it again. We have updated Chrome Frame in the meantime, but if it doesn't work, try it in the Google Chrome developer channel release, and just file a bug and let us know that it's not working for you, and join the mailing list, and we'll work through
But
the
that should be working. That's
It should
not
be
a
working.
restriction.
If the main page is rendered in Google Chrome Frame, yes, it should work.
Okay.
Yes.
I have a few very quick questions. Number one, does Flash just work?
Flash just works.
awesome.
So not only does it just work, we're using the built-in Flash from Google Chrome. So you may have heard that several weeks ago we announced that Google Chrome is shipping Flash 10.1 as part of Chrome. So it auto-updates on the exact same cycle that Chrome does. So you get the latest Flash and you get the built-in version of Flash.
Okay, and then when you're going into beta, are you going to be branding it as beta? Because
Yes, we
people
will.
might be hesitant.
Today it's the developer channel. Yes, when we go into beta, you'll know.
Okay, and then pop-up blockers, how does that work?
So the question was, how do pop-up blockers work in Chrome Frame? Generally speaking, we attempt to plumb pop-up requests back through Internet Explorer. So in order to host a separate window in a pop-up, we do have to ask Internet Explorer to create that window for us, and then we parent a new Chrome tab inside of it in the background.
But the JavaScript can
The
communicate with it?
JavaScript relationship between parented windows should work correctly.
Great.
Yes, you should be able to script them. That's correct.
Thank you.
Yeah.
Can an IT admin specify which pages should be loaded in Chrome Frame? For example, if an IT admin wants to load Gmail or Docs through Chrome Frame instead of having to change the HTML.
So the question was, can I specify which pages I'd like to have rendered that way? And the answer is, yes, you can. If you look at the documentation for Chrome Frame, there's a series of registry keys that we make available to help you configure which pages explicitly through administrator policy you'd like to have rendered in Chrome Frame. You should be careful, though, for applications like Docs or Sites or Gmail, where they may be sending conditional content. They're trying to optimize as much as they can, so they may not be sending the same content to every browser. And if they're not savvy about Chrome Frame and they're not already sort of triggering Chrome Frame, you may get yourself into sort of compatibility worries there. So I recommend that if you're going to do that, you do that only for applications that you control or have tested with. And if you do have problems with Google applications, again, let us know. We would like to understand how you'd like to use them and where you'd like to see that deployed. Also, if you find that the registry keys that we do have made available for that configuration aren't sufficient, again, we'd love to hear from you now while we still have a chance to affect the beta.
Okay, thanks.
Yes.
Just really quickly, the top question, we've pushed pretty hard to get all of our clients onto Firefox because of the IE8 support. Chrome works a lot faster than Firefox with the JavaScripts. Is there a plan to have?
So the good news is that all of the browsers that have sort of been participating in the recent JavaScript performance race are making huge strides. So JavaScript performance in Firefox, DOM performance, CSS performance are miles ahead of where they were even a year ago. And that's part of the reason that we started the Chrome project, was to make sure that we could light a fire under this process of competition. So most of the browsers that don't have majority market share are doing really well at keeping up with modern standards, HTML5. And in fact, as I said earlier, plan A is to get a better browser. We want users to install and use better browsers, and to have those browsers compete head-on to improve their feature set. So we're not going to be making a full-page version of Google Chrome Frame available for Firefox, as far as I know. Generally speaking, there just isn't a great reason to do it, right? Firefox is doing a great job of improving their performance and compatibility story, and we're looking forward to working more with them in the future to make the web more open, and that involves competing head-on. So, yeah.
Does Chrome Frame support Windows authentication? For example, internet web pages that require.
So does Chrome Frame support Windows authentication? NTLM authentication, something like that?
Yep.
I know we have an open bug on NTLM authentication right now. I can talk to you afterwards. If you look through the bug tracker, the Chromium bug tracker in the area Chrome Frame NTLM, you should find the bug, be able to start and see how we make progress. We tend to knock out bugs pretty fast, so you'll get updates on that bug as we power through it and fix it. Eventually, it will work. Yes.
Wondering to what extent, if any, Google will kind of prompt adoption of Chrome Frame through its own websites, such as www.com.
Well, Wave obviously already does this. So Wave today does not support any version of Internet Explorer without Chrome Frame. So you would imagine that as individual properties decide that they want to switch over to using HTML5 features, that they will make an individual decision about where their cost-benefit analysis lies. And hopefully, if Chrome Frame becomes widely adopted, it'll get easier for them to make that choice. But that is up to those individual apps teams. And if you have a particular app that you'd like to see using Chrome Frame, I would suggest that you send them mail. I'd love to be CC'd on it too. Thanks.
Thanks.
Are there other questions? Yes.
I don't know if this has been tried. I haven't been following Chrome Frame, but have you looked at legacy mobile platforms like Windows Mobile and the Internet Explorer that ships with that, like IE6 in most cases?
That's a good question. So the legacy mobile world is difficult, and difficult not only in the sense that it's much more difficult to distribute software onto those platforms. I mean, it is Internet Explorer in some very real sense. But there's also a much more highly constrained memory footprint. Chrome is built for modern systems, so we use the multiprocess architecture because we have enough memory to do it, generally speaking. I think that most web developers that I talk to treat Windows Mobile's browser sort of as the down-level browser. So if you're building a mobile site, you have sort of like your WebKit-based and Opera experience up here, and then you have Firefox experience up here, and then you have sort of your down-level experience. I know a lot of people treat Windows Mobile's browser as a down-level experience, and that might be the right way to think about it. The good news in the mobile world is that things move a lot faster, right? We got sort of stuck in a trough in terms of competition on the desktop browser, but mobile handsets turn over at a relatively rapid clip. Users get new handsets every... I'm sorry?
I'm referring to the enterprise mobile space.
Yeah.
Where it's not that quick.
We have not looked at it. if you think that it's something that would be reasonable to do, we don't have a port of Chrome to Windows CE, and we use Chrome directly for Chrome Frame. So it's something we'd have to have a long discussion about. But if you think it's something that we could do and should do, I encourage you to join the mailing list, and we'll think about it. Thanks. Other questions? All right. Otherwise, thank you so much for coming. And if you have more questions, I'll be in the hall for a little bit, and we can talk about them there. Thank you.